So as I already studied, in statistics, there are two types of tests of significance, parametric and non-parametric. The parametric test of significance, they need some assumptions about the distribution of data. And when these assumptions hold, we can use parametric test. And if any of the assumption doesn't hold, we can go for non-parametric test of significance. So a statistical test that makes assumptions about the parameter may be mean, standard deviation, or variance of the population distribution. The key assumptions are data follows a normal distribution, the first assumption. Then homogeneity of variances. If we are comparing two or more groups, the assumption is that the variances of all the three groups or two groups, they are homogeneous or they are approximately equal. And interval or ratio scale of measurement. The data should be measured on interval or ratio scale. If data is ordinal or nominal scale, we can go for non-parametric test of significance. The examples are of parametric test are t-test, ANOVA, or z-test. The common parametric tests are, the first one is t-test. It has three different types: one sample t-test, independent sample t-test, and paired sample t-test. One sample t-test can be used when we have only one sample and we want to compare that with some given value. And in case of independent two sample t-test, we have two different samples, we have two different groups, and we want to compare these two groups. Whereas in case of paired sample t-test, the samples are paired. Means suppose, for example, height and weight of a person. So height variable and weight of the same person. So they are paired. Or sometimes we test before and after type. Before giving a drug, suppose we measure blood pressure, and after giving a drug. So all this is your paired data set. And in case of independent sample test, we have two different groups. Suppose we want to test the effect of two drugs on blood pressure. So we can have here two different groups. One group will given drug A, other will be given drug B, and we can measure their blood pressure and we can compare this. So this will follow independent sample t-test. And in case of paired t-test, the data will be before, after, or they have some. It has some naturally paired data set. And t-test is a small sample test. We can apply t-test when the sample size is less than 30, or we call it as a small sample. Whereas a z-test, it is a extension of t-test. When we have a large sample size more than generally 30, we call it as a large sample. In that case, we can use z-test. So again, in case of z-test, we have one sample z-test and two sample z-test. Then if we have more than two groups, so we can, in that case, we can use ANOVA, or we call it as analysis of variance. So it is an extension of t-test. In case of t-test, we have two groups, and in ANOVA we have more than two groups. So at the same time, we can compare multiple groups. And in case of ANOVA, we have two types of ANOVAs: one-way ANOVA and two-way ANOVA. And again, the another common parametric test used is Pearson correlation coefficient. It gives value between -1 to +1. -1 indicates strong negative correlation, +1 indicates strong positive correlation, and 0 indicates no correlation. Then one sample t-test test if the sample mean differs from the known value. We have some known value and we have to compare mean of single sample with that known value. In the case of independent t-test, we compare means of two independent groups, and in case of paired t-test, we compare means from the same group at different times, that is before, after, or in sometimes we have naturally paired data. That is, suppose we compare two variables of the same subject. In that case, we can again use paired sample t-test. Then ANOVA, it compares three or more groups. There are two types of ANOVA, one-way ANOVA and two-way ANOVA. In this case, the hypothesis is that all groups means are equal, that is null hypothesis, and alternate is that at least one group is different. So when you conduct ANOVA, it tells us whether all groups are same or at least one group is different from the other groups. So when we conduct ANOVA, to find the significantly different group, we have to further calculate, we have to further conduct post hoc test that will compare pairwise, that will make pairwise comparison. Suppose group 1 with group 2, group 1 with group 3, and group 2 with group 3. So that will be after conducting ANOVA. If we found the difference that at least one group is different, then to find which group is different, we can conduct post hoc test. And here key output is it gives ANOVA gives us F statistic, F value. Then Z test is again an extension of T test. When sample size is large, we can directly go for Z test. Test if sample mean differs from the population mean. And here we know population standard deviation. Population standard deviation is known. Then you can go for directly go for Z test. And for Pearson correlation coefficient, it measures the relationship between two continuous variables. Both variables are continuous, and it lies between -1 to +1. Then there are some assumptions for parametric test. The first basic assumption is that the data comes from a normally distributed population or normal distribution of data. Then homogeneity of variances. The variances of both groups, or if you have three groups, all the groups are homogeneous. They are not significantly different from each other. And interval or ratio scale measurement. The data should be measured on interval or either ratio scale. And the observations, they should be independent of each other. If any of the assumptions are violated, we can go for non-parametric test of significance, like Mann-Whitney U test or Kruskal-Wallis. Any questions regarding parametric tests? These are important. These are assumptions. If all assumptions are followed, we can use parametric tests. If any of the assumptions, suppose data is not taken from the normally distributed population, then we cannot use parametric test of significance. Again, if you have very small sample size, in that case also, we have to go for non-parametric test of significance.
Okay, sir, we can go ahead.
Yeah.
Yes, sir.
So here, advantage of parametric tests is that they are more powerful than non-parametric tests of significance. As the data is, the samples are taken from normally distributed data. So the parametric tests are generally more powerful as compared to non-parametric test of significance. And the limitation is that they are very sensitive to outliers and assumption violations. In presence of outliers, these tests are very sensitive.